everybody, in this video we're going to talk about combinations and permutations that are worth memorizing. We'll cover 8 patterns that have instant answers so you can skip the calculator. To get us started, let's talk about the two big ideas behind every answer, permutations and combinations. Remember, with a permutation, order matters, but with a combination, order doesn't matter. Our formula for a permutation of n choose r is n factorial over n minus r factorial. The formula for a combination of n choose r is n factorial over r factorial times n minus r factorial. Remember, permutations are arrangements where position counts, so maybe like assigning seeds, doing rankings, or making passwords. We use combinations when we're selecting a group. This might be selecting team members or committee members where the order doesn't matter, it just matters that they're in the team or the committee. Our first group to memorize are answers that are equal to 1. We'll start by thinking about choosing nothing. If we have a permutation of n choose 0 or a combination of n choose 0, we can do those in one way. And notice in this case, if we have a permutation of 8 choose 0 or a combination of 8 choose 0, both answers will be equal to 1. The other way to get an answer of 1 is to do a combination of n choose n. Here, there's only one way to choose every item from a group. That means if we have something like the combination of 6 choose 6, there's only one way to choose everything. Our second thing worth memorizing is when the answer is just n. And in this scenario, we're looking at picking a single item from a group of n. Again, we have a permutation and a combination. Because we're choosing one item, order is now irrelevant. So the permutation of n choose 1 and the combination of n choose 1 are both equal to n. So we have another instance when the permutation and combination are equal. A permutation of 12 choose 1 and a combination of 12 choose 1 are both going to be equal to 12. Our third instance involves picking two items. We're going to call this the twin shortcut. So we can look at a permutation of n choose 2 and a combination of n choose 2. For a permutation of n choose 2, we can simplify the solution by finding n times n minus 1. For example, if I have a permutation of 7 choose 2, I can get the answer by multiplying 7 times 6, which is 42. Notice here I have two positions, so I need to multiply two numbers, n and the number just less than n. For a combination of n choose 2, we have n times n minus 1, but now we're going to divide by 2 to get rid of the duplicity that comes from order. So if we look at the combination of 7 choose 2, we'll again do 7 times 6, but now we divide by 2 to get 21. Our last group might make you want to grab your calculator, because now we're looking at a permutation of n choose n, which is equal to n factorial. Here's why. The permutation of n choose n is n factorial over n minus n factorial. We can simplify that. That's n factorial over 0 factorial. It's important to note, 0 factorial is equal to 1, so n factorial over 1 is just n factorial. If we did an example, like the permutation of 5 choose 5, we would get 5 factorial, which is equal to 120.